So when the sun is down and it's raining, solar energy cannot produce as much power, and solar energy can produce some of the most power of any renewable energy. But that's a huge problem. Not only that, now we are looking for solutions with storing energy, but the problem with storing energy is that whenever you store energy, you need some new infrastructure, and whenever you store energy, you lose some electricity, first converting one way, then converting another way. And the longer you wait, the more energy you lose. And the more you need it, and the longer you use stored energy, the more energy you lose. So it might be better just to sometimes generate electricity during the storm for alternative means. Wind energy can be a nice alternative, but it's not always the best. Sometimes rain can actually make a wind turbine not work as well. Sometimes it can make it work better. Rain itself can drain up a little energy because you're pushing it in both ways, and can take a little bit of the wind energy away because the wind is pushing the rain instead of pushing a turbine. Or it can be bad weather and it's spinning faster, but sometimes when the wind is faster, you actually have to turn off the turbine because there's too much for a turbine. So here's some ways we can use rain to make energy without, I think, too much of a radical infrastructure change. One is cooling. So water is some of the best coolant there is, and little droplets of water are even better coolant. Using this to cool solar thermal energy or stored energy and stored in thermal things, which is another way of storing energy, is you heat up something and let it cool down. You can't store energy as heat, then turn into electricity. But cooling it, the more you can cool something, and the faster and the more energy you can get out of it. So you could use it instead of heating up as a coolant. Now some of this might, when you vaporize it, some of it might go back into the clouds and recycle and keep the rain going on a little longer. So it's not going to use up water in that way. And that rain actually does absorb heat from the sun. So it's kind of solar thermal in a weird way, you could argue. Another one is to make temporary streams and put microturbines in them. Now, microturbines are just like doing hydroelectricity, but on a small scale. Now you can look at one out from into the streets and everything. Why don't they capture that power? It's easier said than done because too many microturbines would cost too much money. But if you had it collecting water from a bunch of different locations into a stream, you could put little turbines there just to make electricity for bad weather and kind of stop as a backup. Now, an alternative that I think is a lot harder to design, but will be interesting, is to have turbines actually powered by the falling rain. The falling rain hits the turbine and turns the turbine. The problem with this is that it's a little unusual. Is that you could also combine this with design well. You could combine this with wind energy. The wind would turn it one way perpendicular, would come in perpendicular to the blades and turn it, and rain would come in another way to turn it. So you could combine it. I was thinking about trying to combine it with solar thermal too, but I had a hard time doing that because the problem is that solar thermal, the hot air rising, would turn in the opposite direction unless you take the heater and separate it out and use that to turn it some other way, which I discussed in another video, but that will be a little more complicated. Maybe if you can make it heat the top selectively and turn it in a counter rotational way, maybe redirect the air in some weird way, but that's a lot harder. I would have to think about that. But you could have the falling raindrops turn it. Now, all these systems do not have to be made to be the most efficient during times that it's not raining or bad weather. This is to replace a battery, which means you have a different efficiency problem. And yes, you have the boost that some of these turbines or streams may work when it's not the worst weather. You still rely most on solar energy. But you have to look at it as a battery replacement, which means a different optimization problem. And therefore, you don't have to worry that during the sun's out, it's not making power. You can turn it off. And also maintenance becomes a different problem. And maintenance for a lot of devices like turbines stuff is a huge cost. But if you're only running it 5 out of 20 days a year, 5 out of 20 days, or 1/4 the amount of time, you have a lot less maintenance, and a lot more times that if you turn this whole thing off to maintain it, it's not as a big deal. Also, who's going to maintain this during a bad storm? Well, thank you very much for listening. Please like and subscribe. It really helps the channel out. I'm trying to reach 1,000 watts hours, 1,000 subscribers and 4,000 watts hours within a year, which is a really hard goal. With your help, I think you can do it. Thank you very much. Goodbye.